Welcome to the IUPI Well Completion Equipment Module in the production operations phase of the E&P lifecycle. Before beginning this module, you should be aware that the outflow system is a critical component of the completion design. Understand that specific considerations must be acknowledged to design the optimal outflow configuration. Have basic knowledge of casing designs and drilling, cementing, and perforating operations. Know the primary inflow configurations and bottom hole orientations. Over the course of this module, you will learn about a variety of completion equipment and components. At the end, you should be able to describe the function of packers and tubing, classify packers as permanent or retrievable, identify the source of tubing and packer forces, state the purpose and function of wireline guides, nipples, and sliding sleeves. Explain factors that must be considered when designing completion equipment. The equipment that is installed inside the casing to operate a well in a controlled environment, including any tubing, packers, and other accessories, is collectively known as the completion. There are many reasons to carefully select the right completion equipment for a well. Perhaps you want to maximize production or injection, or you may want to optimize the life of the completion. The task is the job of the production engineer, in cooperation with the reservoir engineer and people from the production operations, intervention, and drilling departments. Sometimes, input from experts in slickline operations, cased hole logging, or force analysis will be required. Together, those involved in the completion design must create an outflow configuration that is effective, acceptable, and feasible for a particular well. In this module, we'll cover some of the main types of completion equipment, including tubing, pup joints, packers, wireline guides, nipples, and communication devices. Tubing is a small diameter steel pipe that is run into the well just above or into the productive horizon. The tubing carries produced fluids to the surface, or injectants into the desired intervals. Lengths of tubing, called joints, are about 30 feet long. The tubing joints are connected to one another with short steel cylinders, called collars. The entire span of tubing placed in the well is known as the tubing string. The tubing string protects the casing from damage caused by contact with produced or injected fluids. A damaged tubing string is much easier to pull out and repair than the cemented casing. Pup joints are less than full-length segments of tubing joints. Pup joints come in a variety of lengths. Pup joints can be placed anywhere in the tubing string. They are used to selectively position various pieces of completion equipment in the tubing string, connect completion accessories below the packer to minimize the length of the tubing tail, and to space out a completion for landing it at the desired well depth. A packer is a hollow steel mechanism with externally fitted elastomeric elements. A packer is typically placed at one or more positions near the bottom of the tubing string. The elements are compressed to form a seal against the inner wall of the casing, forming a barrier in the tubing casing annulus. As the elements are compressed to form a seal, metal slips on the packer hold the packer securely in place by extending to bite into and grip the casing wall. Compressing the elements and setting the slips is called setting the packer. Once the packer has been set, the path of fluids can be confined to the tubing string, preventing the fluids from contacting the casing. Besides protecting the casing and controlling fluid flow, packers support the tubing string, confine fluid pressure to a controlled area, help in certain artificial lift completions, such as gas lift, and segregate intervals. In the next section, we'll talk about some of the different types of packers. The main way packers are classified is by type, either permanent or retrievable. Permanent packers are intended for long-term use. These packers have fewer parts than retrievable packers and can withstand higher temperatures. In a typical permanent packer completion, the tubing above the packer can be pulled from the well while leaving the packer in place. The permanent packer itself needs to be drilled to pieces, a practice known as milling, to be removed from the wellbore. Retrievable packers, on the other hand, can be removed by tubing or a work string, repaired at the surface, and then reused. This allows for equipment changes and repositioning. Retrievable packers are the most commonly used packers and come in many varieties. We can classify all packers further by the way they are set: mechanically, hydraulically, or with a setting tool. And by the way, they are lowered into the well either on pipe or wireline conveyed. Once the tubing is positioned in the wellbore, it will often change size or shape. These changes put stresses on both the tubing and the packer supporting it. These different stresses are called tubing and packer forces. The environment in the wellbore causes these changes. For instance, temperature changes cause the tubing to expand or contract. Pressure increases inside the tubing may cause ballooning. Pressure increases outside the tubing can cause collapse. And compression or pressure can result in buckling. In the following section, we will describe several pieces of completion equipment that are often included in the tubing string. We'll describe when and how to use these accessories, and discuss a little about factors to consider when choosing and placing equipment. Often, a wireline guide, or wireline entry guide, WEG, is run on the end of the tubing. This guide makes it easier to pull a slick line or wireline tool back into the tubing. An angle cut collar or half mule shoe is often used as a wireline entry guide. Another accessory you may use in a completion is a nipple. This device is a joint of tubing with a machined, polished, and reduced inner diameter. Nipples are positioned in the tubing string at various depths, depending on anticipated need. The nipple's main function is to position flow control devices in the tubing, like plugs, standing valves, or safety valves, or pressure and temperature recorders. When you run one of these tools on wireline, slickline, or coiled tubing, the nipple stops it and locks it in place. While it is often best to seal off the tubing casing annulus with a packer, you sometimes need to let the fluid flow in this space. For example, you might need to circulate fluids. In this case, you can shoot holes in the tubing, but this leads to problems later if the holes can't be isolated. The most common solution to this problem is a sliding sleeve. A sliding sleeve can be opened to allow circulation, and then closed to once again seal off the annulus from the tubing. Slickline or coiled tubing can be used to convey the shifting tool that opens or closes the sliding sleeve. With all this equipment that might need to be adjusted down the wellbore, it is possible to put yourself in a bad position. For example, you could use such large diameter tubing that there is no room to shift open the sliding sleeves. Or maybe you could shift the sliding sleeves, but there's just not enough room to circulate as required. When selecting completion equipment, you must choose tubing, packers, and completion accessories compatible with the size and depth of the well. Orientation matters too, so don't plan on doing any slickline operations if the area of the well where you've put your completion equipment is tilted more than 60 degrees. In this case, you may have to use coiled tubing. A well-designed completion will take these factors into account to allow plenty of access to flow control devices and pressure recorders. Now that you've completed this module, you should be able to describe the function of packers and tubing, classify packers as permanent or retrievable, identify the source of tubing and packer forces, state the purpose and function of wireline guides, nipples, and sliding sleeves, explain factors that must be considered when designing completion equipment. In the section on tubing and packers, we covered the use of packers to seal off the tubing from the annulus. We also defined packers as either permanent or retrievable, and described the situations where tubing and packer forces occur. In completion accessories, we saw some of the more common tools such as wireline guides, nipples, and communication devices. We also learned how the size of the wellbore and the equipment must be carefully considered when choosing a completion design. If you are still unclear on any of the objectives, now would be the time to go back and review.